Hello, this is Lorraine Jamison, and this is quiz number 2. So the first problem was separation of variables to solve. Sine 3x dx plus 2y cosine cubed 3x dy equals 0. So the first thing I did was I moved one of the terms over to the right-hand side, and then I divided by cosine cubed 3x to separate both the variables. So once you divide by that, you get the integral of tan 3x secant squared 3x dx equals negative 2y dy. So in order to solve this integral, you would use u substitution. For this, I chose u equals tan 3x and du equals 3 secant squared 3x. So as you can see, you just follow that through with 1/3 u du. And then you take the integral to get u squared over 2, so that equals 1/6 u squared to get tan squared 3x over 6 as your final answer for the left-hand side. And then for the right-hand side, you can just solve normally. The integral of negative 2y is, I just moved it outside to get negative 2y squared over 2, and then you cancel out the 2's to get it equal to negative y squared. So then you have tan squared 3x over 6 plus c equals negative y squared, and then you finish isolating the y variable so that you get y equals plus or minus the square root of negative tangent squared 3x over 6 plus c. For problem number 2, the goal was to place the linear differential equation in standard form and then solve and then find I. The initial equation was x squared dy over dx plus xy equals 3. In order to solve this, first you isolate the dy dx, and you do that by dividing everything by x squared, so that you get the linear form right here, which is dy dx plus y over x equals 3 over x squared. In this case, the p of x is 1 over x, and the f of x equals 3 over x squared. Mu is equal to e to the integral of p of x, so there should be a dx here, but e to the integral of px dx equals e to the integral of 1 over x dx equals e to the ln x, and that just simplifies to equaling x. You multiply both sides by the x to get this perfect integral, integrand. And then, so you take the integral of both sides to get xy is equal to 3 ln x plus c. And then, the final answer is y equals ln x cubed plus c over x, and the 3 as a coefficient is moved over to the x as an exponent, just as property of logarithms. And then, I don't know if you can see that, but the interval of existence for this is 0 through infinity. X cannot equal 0 because the denominator is 0, and also ln of 0 does not exist. So yeah, and every other value 0 to infinity does exist, so that is why the interval of existence is that. Thank you.